Hey guys, welcome to Unit 3, Section 2. Today we're talking about exterior angles and the third angle theorems. Okay, so when the sides of a triangle are extended, new angles are formed called, we have interior and exterior. And we've heard these words in the past, just like when we were talking about alternate interior, alternate exterior, same side, all those angle pair relationships. So these should be pretty fresh. Remember, interior means inside, so you can see they're kind of highlighted here, inside the triangle, and then exterior is what's on the outside that we can see here. So we can actually find the value of x by thinking about, well, what do we know about all triangles? We know that the interior angles have to add up to 180 degrees. So if we know two of them here, these two, we just need to figure out what this angle here is, and then we can find x. So what we should do is take 75 plus 85, and we get 150 degrees. And if we know, or actually no, 160 degrees. So if we get 160 degrees, and we know the total is 180, let's take that away, and then we'll figure out that we have 20 degrees left right here. Okay, so if that's 20 degrees, now we know that 20 degrees and x form a straight line. So together they have to add up to 180. So x just has to be 160. Interesting, because we saw 160 before. So now let's go over here. Let's do this next one. So same thing, let's add up 58 and 19. That is going to give us 77. So together those make 77. Then if we take 180 minus 77, we get 103. So that's what's left for this angle here. And then if we want to figure out, well, what does x have to be if that's 103 to form a straight line? 180 minus 103 equals 77. Again, suspicious. So x equals 77 degrees. So if you haven't noticed, there actually is a pattern for this. It's the exterior angles theorem. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So the two adjacent angles are angle 3 and 4. Remember, adjacent means side by side. So if we add up the measures of angles 1 and 2, which aren't touching angle 4, we actually get angle 4. We really don't have to do anything with angle 3. We only need to know 1 and 2 in order to get it. So if we go back up here, so looking at these before I drew all of this, this would have been 1, 2, 3, and then this was angle 4. So if we added up 1 and 2, we got 160, which was what the value of x was. So it's just kind of like a nice shortcut. Okay, the next one, use the exterior angles theorem to find the value of x. So this time it's a little bit different because we have 1 and 2. Here's 3, which we don't need, and here's 4. So we know that 1 and 2 together have to add up to make 4. So 80 plus x has to equal that 3x minus 22. So I'm going to add 22 to both sides. I'm going to subtract x from both sides. The x's go away, we get 102. And then 3x minus x gives me 2x. These go away as well. Divide by 2, and we get x equals 51. All right. Then we have the third angles theorem. Here's our visual model for it. If angle A is congruent to angle D, and angle B is congruent to angle E, then angle C has to be congruent to angle F. So this goes back to that transitive property, because if it's kind of like if A and D are the same and B and E are the same, there's only so much room left for it all to add up to 180, so C and F have to be the same. So if you think about it, so like here, let's say that this is, let's say this is 40 degrees, This is 80 degrees. That only leaves, so actually 40 and 80 is not a great set of numbers here. Let's say this is 60 degrees. This one can be 80 degrees. So if we take 60 plus 80, we get 140, which means there's only 40 degrees left for this angle to be. So if this is 60 degrees, this is 80 degrees, and all triangles have to add up to 180, there's not another number that we could fill here besides 40. So if you know two of them, it forces the third angle to be the same. So this one says, find the value of x and y. So notice we have the two tick marks for A and F, so that means that angle A is congruent to angle F. And then we have the one tick mark for C and D, so angle C is congruent to angle D. So if those are the same, we know that B has to be congruent to angle E, because that's the third angle, if two of them are the same. So what we can do then to solve for x and y, we already know that C and D are congruent, so just set those equal to each other. 5x plus 1 equals 31. Subtract 1. We get 5x equals 30. I just took these two values and set them equal to each other. Divide by 5. X equals 6. Then what we want to do is we know that B and E are congruent, so we can set those equal to each other. 129 equals 2y minus 3. So let's add 3 to both sides. We get 132 equals 2y. Divide by 2. Y equals, and that is going to be 66. Okay, this is our last one here. Use your vast geometry knowledge to find the measures of the numbered angles and then be able to defend it. We would typically do that in class, but okay. So angle 1. Can we find angle 1? We really don't. We only know one angle from that top triangle. So let's actually look at angle 2 first. If we know that this is 58 degrees, then we know together those form a straight line. So if we take 180 and we subtract 58, we get 122. So angle 2 has to be 122 degrees. All right. Then, knowing the fact that this is 122 and this is a vertical angle with it, we know those have to be the same. So this has got to be 122. And now if this is 122 right here, and the other one's 22, that means there's 144 degrees without angle 1. So if we take 180 minus 144, we get 36 degrees. So that's angle 1. And then if this is 122 and we have 20 over here, we add those together. We get 142. Then we just have to figure out, well, how much is left over for angle 4? So we do 180 minus 142, and we get 38 degrees. And there we go. That's all for this.